So this is our basic homepage, our web page. Now we'll scroll down below. We'll click on get started here. So we need to enter our basic email, phone number and password. For now I'm just going to type a random phone number. So now it's going to redirect to login page. Okay, now you have to log in with your details. Yeah, see, now this is our basic dashboard, our front dashboard. Now here you should see the temperature, pulse and SpO2. So continuing, temperature here, see these are the three sensors that are attached. So this one is the temperature one, and this is your SpO2 and pulse. This is your accelerometer, and this is the main Raspberry Pi which is connected to your webcam over there. The webcam is specifically used for two basic things, that is live monitoring and as well as emotion detection, and we'll show later on. So just see this one. Accelerometer has basically two specific commands that you can trigger. If you move up, it will trigger emergency, and if you move down, it will trigger your need food or need water kind of thing. And these commands are customizable. You can see here. See these. This is a customizable command. The finger up command can be written over here, and a finger down command can be written over here. So we'll just type something like emergency, and in the next one we'll just type need food, and we'll just submit it. Okay, now this is submitted, and if we move the finger up, look at the email. See this. Now since the finger is up, you can see that emergency is being triggered here. The email is being sent to the caretaker on his phone or his any remote device. And if you do the finger down, now any moment you should see an email saying need food and water. See, on the website is now being showed, now it was being showed as emergency, and now when we did the finger down, it is showing as need food and water. Same should be reflecting over here. Yeah, you got it. See here, see you got a new email saying that your patient needs food and water over here. So that is one aspect about the project, and another one is that live monitoring. For example, any patient whose son or daughter is far away and he wants to have a watch over on the patient, what he can do is he can click on this particular live monitoring button, and now a camera that is angled towards the patient will be shown. So he can watch over his ailing father or mother or whoever the patient is remotely. It is based on the concept of a remote CCTV, so you can watch over the particular patient. So that's one aspect.
Okay, so now I'll explain you the emotion detection part of this project. So how does this work? That's the basic question. So what we have done is, we have taken a file from the OpenCV library. Now what is OpenCV? OpenCV is a computer vision library. We have taken harcascade.xml, which is basically like a data set which plots different parts of the faces on the camera video feed. Now as you can see on the screen, his lips, nose, ears, everything has been plotted properly, right? How is this happening? This is happening through a JavaScript code, which is basically taking data points from XML file and trying to plot it on the live video feed, right? So basically, this entire process is segregated into 2 to 3 sub processes. Number one being plotting the face. Now here is the second part. Now what happens is, just plotting the face is not enough. Now we need to do emotion classification. Now how do we go about it? Here we have used TensorFlow.js. Now why TensorFlow.js? Specifically because Raspberry Pi cannot handle TensorFlow Python library. Hence we went forward with the TensorFlow.js. What is TensorFlow.js? TensorFlow.js is an open source library which is being maintained by Google as of now. It is a machine learning library which is used for varied tasks. What we have done is, we are using both OpenCV and TensorFlow.js in order to incorporate the emotion detection part. Now what we have done is, we are using Face API, which is a TensorFlow based API SDK. What is an SDK? It is a software development kit. Now what we are doing here is, we are using TensorFlow and trying to classify all these data points that have been collected using the harcascade.xml file. Now what happens is, this works on a decision tree model. So basically these points are being passed through decision trees and a relative percentage is being calculated as to the person is happy, sad, angry, etc, etc. So there are 6 kind of emotions. So based on these decision trees, percentages of different kinds of images are taken, and after that the highest percentage of the emotion which is detected is being shown on the screen. Now for example, if we can show on the screen, yeah. So here what is happening is, if he smiles, it shows as happy, right? So now how this is happening? So basically multiple emotions might have been detected, but the major emotion which is being shown as of now is happy. So we take the maximum of all these emotion percentage that have been collected, and this is how the entire emotion processing works. Now how the Face API min works, right? How the Face API works? Now what we are trying to do here is, we are using TensorFlow in order to train our model. Now what is the data set? What is the basis of classifying all these images? How does that work? So basically what we have done is, we have used an open source data set which is under MIT license. Its name is FER 2013. Basically it's a facial emotion recognition library which was introduced in 2013 under the MIT license. Now what does it have? It has several folders with multiple images of each kind. For example, there is a folder for sad, there is a folder for happy, there is a folder for surprised. Each of these having maybe 100k images, 150k images, right? So now how does this work? Basically classify the data set into 2 portions, which is 60% and 40%. What is 60%? 60% is basically your training data set and 40% is your testing data set. Now how does this work? So basically you train your entire model feeding the 60% of the data, and then you try to test the efficiency of it using the rest 40%, right? And when you take these 2 metrics and plot them on an Excel sheet, you try to calculate what is the F1 score. So for our project, we got an F1 score of 95.7, which is pretty effective.